हरिः कर्ता।
So now we have seen enough theory. So now it's time to explore these measures of association on real world data sets. We will take correlation, covariance, as well as we will use scatter plot to visualize the relation between the two variables. So why to wait? Let's jump into the pandas and Jupyter notebook. So this is what the data set that we have used so far, and we have done a correlation and then covariance. Now it's time for the scatter plots. Okay, so let me take the first one as it is, same data, paste it here. So my pandas is ready. Now only thing is I need to plot the so let's create a scatter plot x and y and see how they look. So for that I need to import matplotlib dot pyplot as plt. So plt dot, I'm gonna go with the scatter plot, scatter, and dfx, that would be our x-axis, and dfy, that would be our y-axis. It's a capital and this is also capital. That's it. Your scatter plot would be ready by now, but let me add the x labels and y labels for it. So x label, this is x, and y label, this is y, and plt dot title, so scatter plot of x and y, and finally plt dot show. And okay, let me check here. I have defined as dfcv, so dfsp, so that's what my scatter plot. Let me say dfsp, dfsp, and this is your data. Oh, fantastic, it's clear cut negative correlation. So when x is 1, y is 5. When x is 2, y is 4. When x is 3, y is 3. When x is 4, y is some 2.2. And when x is 5, y is 1. It's clearly reduction. It's clearly reducing. They're inversely proportional. So y is inversely proportional to x. This is negative correlation. Now that's what we got the values here. So negative correlation minus 0.99, and that too it is linear. It's a linear. So it's a linear, it's a strong negative linear correlation. Okay, so now let's take the second data. This is what is our second data, and paste it here, and take the same information and paste it here. Let me change this to SP and execute, and this is what this is clear cut positive correlation and a linear. This is positive and a linear. See that it's a linear. And y, this is a dependent variable, this is independent variable, y dependent on x. So when x increases by 1 unit, y is increasing by 2 units. When x is increasing by 1 unit, so y is increased by 2. and Yx is increased by 1, Y increased by 2 units. So there is a clear cut direct proportional to the X. So Y is directly proportional X, and this is a strong positive linear relation. That's what it conveys. So next one, let's see how does it look. um, the final one, let me take only data. This is no relation, and here you can see the this is a 0.399, the positive correlation. You see that this is the positive correlation, and you can see the covariance also. You have 5.4, the strong covariance in this way, and here you have minus 2.5, still here also a strong covariance. So now let me check the another data, and let me copy this here. So let me change this to SP scatter plot, and oh, this is what the data it is, and it's completely, there is no specific relation, it's a random relation. So that's the reason the correlation that you got here was 0.0. It's close to 0. So close to 0 is no relation, the correlation is 0, and whereas the covariance is 9.0. Some, okay, the change, when something changes, something will change. How much it will change, that's what the covariance is saying. Okay, so this is the data that I've created, and I just want to simulate the positive correlation, negative correlation, and the no correlation. So that's what you've seen here with the scatter plots, with the visual representation also. So now let's get into the action with the real world data sets, and let's see how it behaves. It's fun. So let me go with the soccer players data. Import os dot dir list, sorry, list dir. Yep. Now let me bring the players data. Pd dot read csv, and read csv. I need to go with the respective file, soccer players. Let me check the players now. Yes, our data is ready. In this, I'm gonna go with the height in centimeters, weight in kg. Let's see how it works. So first, let's calculate the correlation, then we will go for the covariance. So I just want to see the correlation between the height and weight. So first one is the correlation between height in centimeters and weight in kg. Okay, so I'll call it as correlation between height and weight. So let me bring the data. So this is players data. So players, and what's the, it's, I want so what I want to see, what I want to tell is here the weight is the dependent on height. That's what I'm saying, that's what I want. So weight is my dependent variable, height is independent variable. So if height increases, weight also increases. That's what my hypothesis. Let me check what's going to happen with this data. So players of weight, this is my independent variable. So this, and my dependent variable is dependent on this players, and this is height is my dependent variable. Okay, so what I want to say is I want to measure the correlation. So correlation of, So correlation of y with, so correlation of this. Now let me, so correlation of so y, correlation of y with x, that's what I'm saying. Anyway, let me check this way first and then I'll check the other way. So let me print this one, print correlation core height. So that's okay. It's 0.77. That's fantastic. It's pretty close. It's positively correlated. Let's see how it looks. Let's see how this data looks. But here what I said is, let me write down here. So for me here, in this case, dependent variable is height, and then independent variable is weight. That's the case here. Now let me do it in a different way. So I'll place y as my weight. So y as my weight, because what is my hypothesis is, if height increases, weight also increases. So for that, what I'm gonna say, my y, that is dependent variable is equal to weight. This will be dependent on a variable called independent variable, that is our height. Okay, this is what the hypothesis. So my equation, I don't know. So weight is equal to some m times height plus c. Okay, this is what my equation. That's fine. Now obviously I need to have a correlation of weight with height. That's what I want. So let me take the same equation, and this is what I want. So correlation of weight with height, that's what I want. And it's same. So it's same. Let me put it here. Correlation of weight with height. I just change this, change the dependent and independent variable, nothing much, just to have a clear cut understanding. Okay, so we'll go with this way now. So now let's calculate the covariance between weight and height. So we got the correlation of 0.77, that's Pearson coefficient of correlation. So now let's calculate the covariance. So everything remains same. Let me take this exactly and paste it here. So rest all remains same. Here it will become so covariance of weight with height. Let's see how it works. So I'll just say covariance, and here I'm gonna say covariance, COV, and here also I'm gonna say okay. Okay, this is what the mistake here. I got the point. And this is height, and here also I'll give height and weight. And okay, it's too much. 139.985587. What it says is it has a very strong connection. Okay, very strong relation or change covariance with uh, between weight and height. That's what it's saying, because you got the very bigger value. And the third one, a fun one, that's the scatter plot. Scatter plot between, again, weight and height. So for the scatter plot, I need to import matplotlib. First, let me import matplotlib. Pyplot as plt. So now rest all falls into the place. So plt dot scatterplot, and our x-axis, first let me give the x-axis. So x-axis is obviously height in centimeter, height in centimeter, and then y-axis, that's in weight in kg. Okay, players weight in kg. What's the issue here? And so that's it. Let me add plt dot x label. So x label is height in centimeter, and plt dot y label weight in kg. And let me put the title. Title is scatter plot of weight and height of the players. And finally, it's time to show. plt dot show. And here is that. Oh, fantastic. Okay, clearly you can see the outlier here, one outlier. And other than that, you can say that there is a strong positive linear association between weight and then height. See that? And everything got proven now. Correlation, covariance, and then scatter plot all together. So 0.77 is your correlation, and 139.98 is your covariance, and then scatter plot, which has visually represented whatever mathematically done before, statistically done before. Yep, this is what is our scatter plot of weight and heights of the players. So let's take another example. Let me get up. Yep. So customers buying pattern, customer segmentation. Let me go for the customer segmentation this time. So customers is equal to pandas read CSV, and then let me go for the customer segmentation. So customers Yep. So from the customers data, I just want to, of course, age and then annual income. They won't be. Okay. So what I will do here is I will first try to find out, is there any specific relationship between annual income and then spending score? Whether the annual income, whether the spending score is dependent on annual income or not. That's what my first, and after that I'll go for the, is there any specific relationship between annual income and then family size, and then annual income and then work experience. Let's try to do it one by one. So first target is to find out, explore the association between spending score and annual income. So now what I'm going to do is I'll begin with again correlation. So let me take a correlation. Let me copy this here and paste it here. So correlation between our y, our dependent variable here is spending score, spend, and annual or just income. So this is customers, and the data, of course, this is x. X is our annual income, and I want to see whether the spending score is, whether the spending score is associated with annual income or not. So sorry, spending score, let me check. Okay, spending score, let me directly copy this from here and paste it here. Yes, and let me call for the correlation spend income. And there was an issue with spending score, key error. Let me check what is that. Yep. Players dot columns. So let me take this one directly. Sorry, this is not players, this is customers. I'll go for the spending score from here. Oh, okay, okay. I have taken the wrong one. I mentioned the players here. Okay, sorry, that's my mistake. So customers and spending score. Oh, it's very less, 0.023. Of course, it's closer. It's 0.02. So it's very close to 0. So we can say that there is not much of relationship between the annual income and their spending score. Now let's look into the covariance. Covariance. Let me bring the same one here. No, just copy this one exactly. So not much of changes. So just change this to COV and change this to COV. Change this to COV, and this one would become covariance. Oh, this is huge. 29,770. So the covariance is saying if there is a change in one will cause a change in other, so huge amount. But the correlation is saying the relationship, their relation is not neither uh, positively correlated nor negatively correlated. They don't have a specific kind of a specific kind of relation, but if one changes other changes without any specific trend. That's what this data is telling. Okay, now finally let's go for the scatter plot. So directly call, let me put, okay, for me, this is x axis and this is our y axis, and I'm gonna put annual income as x label, and spanning score as y label. So scatter plot of the spending score, spend, and spend and um, income of the players. Oh shit! What is this? Okay, okay. Obviously there is no relation. There is no relation. This is weird. Okay, but anyway, we have seen these kind of plots, no, in our data sets, in our slides. Okay, this kind of representation, if data points are if they don't take any specific trend or pattern, then there is no relation, so no correlation. So that's what our correlation is 0.02, which is lesser. It says there is no correlation, and even our scatter plot is also conveying the same. You can clearly, that's what a scatter plot is, part of the measures of association, because that's what makes a visual representation of your correlation. Whereas the covariance says there is there is a good amount of covariance, means if one changes other also will change. That's what it's saying. Okay, now let's get back, and second one we will check, is there any specific relation with the association with the annual income and work experience. Let's see how this behaves. Oh no, let's explore the association between the annual income and family size, sorry, work experience. So is my annual income dependent on work experience? That's what I want to see. Let's see. The customers, is the customers annual income is dependent on, is associated with work experience? That's what I'm going to explore here. And as usual, let me check, the first one is correlation, and let me take the code from here. So it's correlation and income is dependent, is associated with work experience. So let me take first, customers annual income is correlated with the work experience. That's what I want to check here, and the rest all remains same, and execute. Oh, this is slightly better. It's 0.089. It's 0.089, but still, no, it's not so great. It's not so great. It's not that. It's no work experience uh, is not directly associated with that. Okay, let me do it in other way. Okay, the annual income is not directly is not directly correlated or indirectly correlated with the work experience. Now let's check for the covariance. Let me copy this exactly from here and paste it here, and let me say cov, and rest all remains same. Cov, this will become cov, and this one will become covariance, and execute. Oh, this is also huge, 15991. So now let's finally go for the scatter plot. Yep. So let me copy the scatter plot and see how it will look like. So x-axis is our, let me check, x-axis is our work experience, and y-axis is our annual income. Sorry, customers let me just simply bring this one and paste it here. And x label is work experience. Let me put it as x label here. And y label is our annual income, and title in between the income and experience of the customers. That's my mistake. That's customers, not the players. Hey, what is this? Okay, we got some type of data. Okay, that's how it works, because 0 to 17.5 years of experience, and then so you have lot of lot of customers who holds similar kind of experience, but with different annual income. But this says there is no specific or clear cut correlation with work experience. The annual income does not completely dependent on work experience, because if you see, the one with work experience of 0 will still have $1,75,000 of annual income, and the one with 17.5 years of experience also have a lesser package, that's 75,000 or 60,000 USD. So that's what it says, and that's why you got the 0.089. That's your correlation coefficient, and then this is your scatter plot, which says there is no relation. That's what. And the final one I just want to check is again the annual income and family size. What I want to check is the family size dependent, or is the family size associated with annual income? So just want to explore the association between family size and annual income. Yep. So let me take the correlation first. Copy the code from here, and with minor modification. Okay, with minor modification. So let me take this. So family size and income. So my Y is family size, and my X is annual income. So correlation, and this one will become core family income. This is 0.09. So this is also very low. Obviously we'll get some this sort of picture only, nothing much. There is okay, covariance. Let's just calculate this. uh, let's put it here. Okay, 8383. Okay, finally let's put it into a scatter plot and see what kind of weird picture that we're gonna get here. So this one, our X is uh, annual income, and our Y is family size. Okay, directly copy this, paste it here. Next label, annual income, and Y label, family size. So in between, plot of income and family. Got similar one. Okay, so family size, again, it's not, there is any specific. Okay, when even with the family size of one, still you can be a rich, no. And if you family size of 7, still you can be rich. So there is now the annual income. So it's not that the annual the highest annual income only has the biggest family. No, you have you with the lowest. Some customers with the lowest annual income, still they have 7 6 big families. Okay, so that's the reason it's 0.09 is correlation, and then your data, the scatter plots also gives some weird picture, which obviously conveys that there is no relation, there is no specific correlation between them, there is no specific association. So that's what some of the examples you can keep on exploring with the some real world data sets, so that you can have that hang of it, you can get that hang of understanding and working with measures of association.